that was unfortunate. So welcome to Couchbase Coding with Matthew Groves. This is a 10-minute slice of my day as a developer advocate, live every day on Twitch, YouTube, and Periscope. Please email me or tweet me your comments, questions, suggestions. I'd love to hear from you. The music today was Longing for Tumbleweeds by Admiral Bob, same as yesterday. I really like that song. So I started a stream about 6 minutes ago and didn't realize until someone mentioned it in the chat that my microphone was not actually sending any sound to the stream. So all that wisdom that I was speaking to you was lost into the void. I'm going to start over again and get through the stream. I can see the microphone line actually dancing now as I talk, so I need to make a note of checking that next time to see what's going on there. So thank you, MiniWheat1982 from Twitch for pointing that out. And sorry about that. Anyone who's tuned in, watching me just sort of flap my mouth and not making any sounds. Okay, so I'll start over again. So I was asking Google to give me some more questions, and yesterday we did how many NoSQL databases are there. This time we'll be how many types of NoSQL databases are there, and that's an interesting question. It's kind of tough for me to give an exact number or list them all. But I'm going to try my best, and I actually put this little notepad here on the screen. I listed a few of them out. The big four people usually think of is key value store, document database, wide table, aka columnar, and graph. There are other kinds as well that are interesting. Object-oriented databases, or time series, or search engine databases. But I generally like to focus on these four. Talk about NoSQL, and there's some other ones that I'm missing as well. It's a pretty big umbrella, this term NoSQL. It covers a lot of ground, and there's new databases all the time, new types of databases, new use cases, things like that. But those are the big four I want to cover. So let's start here with dbengines.com. This is a page I showed you yesterday. Not affiliated with Couchbase, but they do feature us there on the page, so that's very nice. But this is a third party, and they have this encyclopedia here. So I clicked on the encyclopedia link, and I get this nice little index of terms. So we'll start with each of these, and we'll go through them and see how far we get. So key value store is probably the simplest form. It says right here, simplest form of a database. You basically store a key and a value. It's a big dictionary. Think of it like that. And you can retrieve values if you know the key. And that's the only way you can retrieve values is by knowing the key. You can't actually examine the data inside the document until you actually retrieve the document. So you typically don't have indexes or other ways to query the data other than just those keys. And so some examples of that are listed right here. One note is that Couchbase actually still has memcached support, or memcache, I'm not exactly sure how you say it, support as sort of a legacy system. And memcache, or Couchbase, was kind of born out of some legacy of memcached. So Couchbase should be on this list as well because it also can act as a key value store. But the idea here is that some of the use cases for these as pure key value stores are very simple. And I mentioned you can't query stuff necessarily by the values in the key value pairs. And so these are really good for things like caching or a session store or other sorts of really simple storage mechanisms. In fact, at least three of these, Redis, Memcached, and Hazelcast, these are all designed for caching. And so this is kind of the ideal database to use for caching. And since Couchbase is not listed, I'll just sort of use Memcached as a proxy for that, because Couchbase does have a memory-first architecture as well. It can also be used for caching, for session store, and things of that nature. Okay, and so one other comment I wanted to make is that this kind of mentions a little bit is that it's easy to have these nice neat categories and say this is key value, this is document, this is graph, etc. But there is some overlap, and there is some people these databases are not just done, they're not just complete, they're adding features all the time. So there is lots of blurry edges, I guess you will, sort of loose borders between these types of databases. So it's kind of helpful to talk about these. It's more specific than using the term NoSQL, but just keep in mind that there is some blurring the lines sometimes. And it really depends on your use case and what you're trying to do with NoSQL. So let's go from key value to document. You can think of document as a special case of key value, or perhaps a more advanced version of key value. And the idea here is you still have keys and you still have values, but the values are some sort of defined format. And typically that means JSON. But it could also be XML or YAML, I guess, or whatever other sort of defined format. But I mean, for the most part, it's JSON and a little bit of XML in there. And JSON's nice. It's readable. It's relatively compact. It's the language of the web, basically, kind of the data language of the web. So the same sort of data you use on your front end, you can use in the back end as well. That's very nice. And these things are all true. Nested structure here. So I was looking up, his name was escaping me in the earlier stream, but it's Martin Fowler. He calls these document stores, he calls them, they're also called document-oriented. He calls them aggregate-oriented databases, because you can think of a document as kind of the aggregate root of a piece of data, right? Which means you can have a nested structure. You can have more complex than just a flat piece of data. You can have arrays and hierarchies and objects within objects, and so it can be a lot more complex, and it can map very easily to a Java object or a C# object, because there's no impedance mismatch. It's just you can serialize them one to another and deserialize them one to another. Some examples here. It lists, of course, Mongo, Dynamo. Couchbase is here as well. I mean, I would consider Couchbase more of a document database than anything, but it can certainly act as a key value store. CouchDB is on here as well, and Cosmos. So that's document stores. Two other kinds we're going to get to. We should have plenty of time. Wide column, also called columnar sometimes. These are a little difficult for me anyway to think about initially when I was first trying to learn about them. But I think the easiest way to sum it up is that it's kind of like a key value store. You think of key value store as a giant dictionary. Well, think of it as columnar or wide column store as a dictionary of dictionaries. All right, so you have a dictionary that has a key and some value, and the value itself is a dictionary that has a lot of keys and corresponding values. So it's kind of like that. Kind of think of it, yeah, a two-dimensional key value store. That's kind of what I just said, a little bit. They are also flexible in their schemas, kind of like a document database. It doesn't have to be the same structure of data from record to record, but the implementation is different, and the data in a wide column store is typically going to be flat, right? It's going to have similar sort of impedance mismatch issues as a relational database, but with the benefit of being more flexible than a relational database. What else? Okay, some examples here: Cassandra, HBase. I mean, that's really kind of it. There's not a lot of big table or wide column databases out there. Big Table is a white paper that kind of led to these. But yeah, Cassandra and HBase are kind of the two big ones. Cosmos has implementation as well, but it kind of used the Cassandra API to deal with that. So interesting stuff there with wide column stores. One more is Graph, and these are interesting. Graph Database Management System. These represent data in graph structures. So graph structures means there's nodes and edges. So you have a piece of data, which is a node, and an edge that connects that piece of data to some other piece of data, and that is the relationship. So I often give a fun example of Star Wars. So I'd have Luke Skywalker and Darth Vader. They're two pieces of data. Those are two nodes in your graph database, and they have an edge between them. And maybe Luke Skywalker's is directional edge to Darth Vader and says, is son of, spoiler alert, is son of Darth Vader. All right? And then you could have another edge going from Darth Vader back to Luke Skywalker and saying, is father of. So you have these edges. They can be directional, and they can contain information of themselves. Now, one thing it mentions here, I'm not sure if this is actually true of all these, but they don't usually provide indexes on all nodes. That's kind of interesting, which means that it's kind of like a key value store in that you need to know the key or how to get to the data up front. But the interesting thing is once you have that, you can do some very interesting things with graph queries. So, for instance, I could say, okay, find all the enemies of Luke Skywalker that were in The Last Jedi. All right, and I could, based on the edges, I could go through and navigate that graph. It would navigate it for me and return results. But you could also do some more interesting stuff in the real world, like you could say, all right, I want to find all the customers of my grocery store that have purchased beer and that have purchased diapers. And so I could make some implications about those people, and I could send them certain coupons, things like that. So it's when you're talking about data relating to each other, this is kind of a step further than relational. Relational is, we have a key, a foreign key, some arbitrary number or GUID that relates this piece of data to this piece of data. A graph database takes it a step further and says, okay, a relationship is a first-class concept. It's not just an arbitrary number connecting things. It's an interesting piece of data that we can use in the query. All right, so those are the 4 main types of NoSQL databases that I usually talk about. Other ones are also interesting. Definitely check those out. Couchbase is a multi-model in the sense that you can do both key value and document database with it. And it is kind of built on the legacy of Memcached, compatible with Memcached, I guess, but it is a memory-first database, so it's great for those caching session use cases, but it's a document database, so it's also good for those more complex systems that require indexing and rich data structures and so on. All right, well, that's it for today's stream. Sorry for the false start if anyone's still watching. No audio, the first attempt of the stream, so I apologize for that. But tune in tomorrow and we'll continue asking questions of Google. Or send me a tweet, send me an email if you have questions about NoSQL or Couchbase or anything. I'd love to hear from you. Information at the top of the screen there. And that's it for today. Thank you very much for watching.